Good. No, sorry. Okay, so fundamental theory of calculus. Okay, FTC. Okay, it's referred to as FTC quite often. It's talked about all the time. Fundamental theory of calculus is we can break things up into different things. Okay, so tells us that differentiation and definite integrals are inverse operation, just like that we have multiplication and division are inverse operations of each other. So, to approximate the slope of a tangent, it's dy, right? The delta y over delta x. To approximate the area under a curve, it's delta y times delta x, where this is given as the function.
The delta y.
So using velocity to investigate the FTC, what did I say FTC is?
Fundamental
theory of calculus.
Ooh, look at it. Someone paid attention.
Or we just read the title of the note.
Okay, find the displacement on the interval. Okay? Using velocity, find displacement on the interval from 0 to 2. 0 to 2. Okay, so if I was to try and look at that, if I were to look at a graph, because S of t is my position, right? So let's take a look. S of t is position and V of t is
Velocity.
or I could also refer to it as the S prime of t, right? So it's almost like, actually, hold on. I think I have it on the next page. Oh, wrong. Right there. So for this, it comes up. Is it? I have it on the notes. What did I do with it? Here it is. Okay. So finding the displacement or the total distance traveled. Finding the displacement or total distance traveled.
Using position equation.
Okay? So, we have to find the distance traveled, it has to do with my velocity, doesn't it? Displacement means, okay, so I'm going to tell a story and you're going to tell me what the displacement is here. Okay? We have Sir Brian. Okay? You can get dated. Alright, Sir Brian walked from here over to Douche Bros, and he was walking back and he got hit by a bus right in front of Brophy.
Wait, you can't say that because YouTube's
No, I can say that because I'm not using the actual business name.
You said a word.
No, I'm not using an actual real business name. So, it's a fake business. Okay, so walked over there, walked back, but got hit by a bus in front of Brophy. So his displacement would be what?
The distance from here to Brophy.
The distance from here to Brophy. That's what the displacement is. Okay? That's what my displacement is. Now for total distance, my total distance, he didn't walk only the distance from here to Brophy, right? So my total distance would be from here, Douche Bros, and then back to Brophy, right? That's going to be the explanation of the difference in between displacement and total distance. Total distance is the full amount that you walk. Now, displacement would be your distance, how far you are from your starting point at that. Does that make a little bit more sense?
Yes.
And these both refer to what? My velocity, right? Okay, it has to do with my velocity. So I'm going to use that. Okay, I'm going to use that here. Okay, so now, find the displacement on the interval from here. Okay, so here is my velocity, right? So from here, I'm going to find the derivative. The derivative would be what?
14.
4.
40.
4t is my v of
T.
t.
Your A of T would be cool.
Okay? So there's that, right? So now, we're going to take the velocity, right? So to find the displacement, it would be the integrand, right? From where to where?
From 0 to
0 to of my velocity, which is
4T.
and it's going to take the integration according to which variable?
T.
dt.
DT.
Okay? So now, let's go ahead and do that. What do we get?
Let me get my calculator out.
So I'm going to get 2t squared, right? Does this one right here have a c to it?
No.
This one does not get a c, does it? And bar, so it's from 0 to 2, right? And that breaks up into, it's going to be, this is going to be 4, right? 8 minus 0. Yes, that guy.
What is the point of deriving it?
What happened? So when we're doing this,
Just-
we're doing this in terms of the velocity, right?
Yeah, but we're doing like
Okay. Is this the same as what I did here?
Okay.
No, right?
Yeah.
It's not the same as what we had there. And so I'm using this for here. So it's going to be 8 minus 0.
Okay.
So from my velocity, that's what I have to get. So from my velocity, I'm using my velocity for this. Okay, so now we have this. So if I did this, it's going to be plus 1 t squared. So 2t squared at 1, it's going to be 2. And at 2, it's 4, it's 8. 1, 2, 3, 4, 5, 6, 7, 8.
Are you doing it from SFC?
Yes.
So would it not have been 3? 1 for the second one?
So we're trying to find this.
Yeah. With the second dot, it would have been at 3 instead of 2. So that's the 1 squared times 2 plus 1.
You're right. You're right. Should be 3. Sorry. You're right. See? Someone knows what they're talking about. It's not me. 8, and this should go up to 9, right?
Yeah.
She said 10. Why'd she say 10?
Wait.
Because she added an extra 1.
Damn it. Zero's pretty low.
Okay.
I meant to say like
Oh, it's not.
0 plugged
Okay.
into this.
Anybody got colors?
Make sense?
You want colors? What do you want?
Okay.
Purple?
Fundamental theory of calculus.
As long as it's not black.
So, integration of the top
Purple.
minus integration of the bottom. Remember, we do integration is the capital letter F. So the signification is that when I'm taking integration of F, it gets me my F capital. Right? Okay? Where F of X is continuous over that, differentiable in all AB. What does that mean?
In the
Integral of A to B, but does it have to be differentiable on the ends? Does not have to be differentiable on the ends. And F prime of X is going to give me just F of X. So if I take the derivative of my integrand, it's going to give me my function again. I used a whole bunch of big words today for this.
function?
Function.
There's more numbers.
I know.
If
What
there's
the
more
function?
letters, numbers it adds
Okay, so now for this one right here, can you find antiderivative of F? Show a way to evaluate the definite integral without using limits of a sum. Now, a couple things. There is a way of doing it. properties of definite integrals. Okay, from A to A. So the same point to the same point is going to give me 0. Okay, because your delta x is going to be 0 here, right?
Yeah.
There is no thickness for this. There is no thickness. So to find the area under any curve with 0 thickness, so the height could be 100, but the width is 0. So that's what that means. So right here, this is my delta x. How far are those apart? So to find, if I was going to try and find the area of that, this minus this is my delta x. That's my dx right there. So this piece is 0. So the width of any rectangles or any shapes that I make out of this is going to be 0. Okay, to find the area under that, you know, whatever the height is times 0 of my width. That's what I get for this. So now on the integral from A to B, okay, I can go from like this. It's going to be from A to B. If I go this, I could also have opposite. I could change this. There's some times in which that you are going to need to change this, because if my integral does not work out for what I'm working with, because I have like a negative or something in there, I want to but still find the area, the total area. Okay, I'm going to do the opposite of this. So I'm going to change my integral, because that means that I'm going to end up with a negative out of this. So I could change this from, instead of reading it from left to right, I'm going to read it from right to left. And it means the same thing. Yes, no, maybe? Yes? Hopefully. Well, you know what? It will apply better when we actually do some more. So this one right here is if we have somewhere we have to do A to B, but if we're doing, we're going to end up with something like this eventually. So you're going to have a graph. We're going to have a line going like this, and I'm also going to have a line going like this. So if this is my A and this is my B, this point right here in between there is going to be the C. So we're eventually going to change. So if we're having this right here, this would be the area of the top minus the bottom. If we're only looking for this, I'm just trying to give you guys an explanation of why we're doing this. So do me a favor, try and stay awake. So we're just trying to find the area in between these two curves. So it would be the top minus the bottom. But at point C, it changes to now be the other line is going to be on the top, right? So it's the top minus the bottom. This is the area of my first piece here, because I had to find a point C that is somewhere in between there, where those two lines intersect somewhere over my interval, plus the area of my second side from C to B, from here to here. So this one. So I have this area plus this area. Okay, so now let's take a look at this problem. All right, so I'm going to go back to a normal color. Okay, all right, so if I'm going to do this one right here, do the integration of this. What are we going to come up with? Integration, what happens? Add 1. So it's going to be x to the third over 3 minus. Okay, and now, this is the point in which I normally put the C, right? But since it's not, so it's going to be from 1 to 2. Okay, so let's do this. So I'm going to get 8 over 3 minus 6, right? Minus my lower bound, which is here. It's going to be 1 over 3 minus 3. So this is going to be, what's that, 18 over 3? And so it's negative 10 over 3. Do you guys see what I did there? Okay, so common denominator. And this is going to be 9 over 3. So this is going to be 8 over 3. Negative 8 over 3, right? The two negatives going to make it a. So this is now going to be a plus. And so I'm going to end up with a negative. Now, what does that mean about my area? Okay, yes it is. Exactly. That is negative. But where is my negative values for this? Say it. Under what? Not the curve. Under the x, right? Under the x. So if I were to look at this, it would be under the x.
Wait, like under the axis?
Yes, under the x-axis. So let's see if I could pull this up real quick.
The area, so the line is under the x-axis, and you're taking the area between x, between that line and the x-axis.
Yes. So let's see.
It's like in quadrant 4.
So let me see. Integration x squared minus 3. Okay? So watch this. So I'm going to do right here, math, integration, so here it is, math, and this is from where to where?
1 to 2.
1 to 2? 1 to 2 over x
Squared minus 3.
x squared minus
Is it
3.
the original or are we not putting the original?
I am putting the original.
Okay, then x.
And dx, right? Okay, there we go. Negative 2/3. Now, I'm going to show you guys this, the original. So for right here, I'm going to graph my original. X squared minus 3, enter. Now, from right here, I'm going to do menu, analyze graph, and I want the right here. So the integral, so now I don't have bounded because it's not going to be 2. So it's going to be, so now I have a little track thing right here. So all I have to do is actually hit the number, what was my lower bound? Hit enter 1. And the next one is? What? There we go.
Can I get a replay of that? Instant replay, please?
It's almost like I have a video for this.
Yeah, I think so.
Makes sense now?
Can you send it to New York? Or
Wait, so the area is 2/3 or
Negative 2/3. Why is it negative 2/3? It's under the graph. The area is under the graph. So now, if I was talking about this in terms of displacement, think about displacement. Okay, if we're going to douche bros over there, so I am now further away than I was going, right? So I went the other direction. Does that make sense? So there's my displacement over there.
Oh, wait, so okay, this is line. Oh, I got it.
But now if I'm asking for my total area, my total distance, right? My total distance. So I'm not traveling negative distances.
You're just going the opposite.
I'm going the other direction. So how far did I travel? 2/3.
Two turns.
Does that make sense? So my traveling, I walked 2/3, but then my displacement means I went 2/3 in the other direction,
I just had an epiphany. Looking at the
going
graph.
away. Right?
It makes sense.
It does.
It makes sense now.
So that's why I like the graph. Okay, so you like me again, or no? All right, so you guys, we got some practice problems. I'm not going to put it all in the video, so you guys got the basic of it.
Like, share, and subscribe.
Like and subscribe. Don't forget, 100 views. That means Jonathan is going to eat one of his Kanye shoes.